So in this question, it's given that three circles, they are touching each other. Also, their centers are in one line. So this black line, all the three centers are lying. And there is one common tangent for all the three circles. For the two smaller circles, the radius is given as R1 and R1 is 4 centimeter and R2 is 6 centimeter. We have to find the radius of the third circle. So before we proceed, let's assume this radius R1 will take it as A, R2 will take it as B, and R3 is C. So this particular length is your A. This will become B, B. This is C. Okay, tangent, the property is that the radius is perpendicular to the tangent. So from A, I am drawing this tangent here. Sorry, this radius. So from center B and then from center C. So these are the radius. Of course, their length will be same. That is A, B, and C. Now we are doing a construction here. That is, to this black line, we are drawing a parallel line. So this line is there. We are drawing a line parallel to this line from the tangential point. So this line which I have drawn is parallel to the black line. And from here, I am drawing a line parallel to the black line. So these lines are parallel to each other. Also, if you will see, all the radius, they are perpendicular to the blue line. They are perpendicular to the tangent. So this angle is 90 degrees. Here, this angle is 90 degrees. This angle is 90 degrees. So for all these three radius, this tangent is acting as a transverse and these corresponding angles are equal. So we can safely say that all the radiuses are parallel to each other. So these are parallel to each other. Now, if you look at this particular figure, now this quadrilateral, opposite sides are parallel. So if opposite sides are parallel, then this is a parallelogram. In parallelogram, the opposite sides are also equal. So we can say that this length here will be same as A, and the length which is there on top, so this particular length will be nothing but B minus A. So instead of B, I am writing this particular length is A, and the length on top is left is B minus A. Same way, this length, for this length, we can say that this figure, opposite sides are parallel to each other. So this figure is a parallelogram, and this length is nothing but B. And the length which is there on top will be C minus A. Okay. Now let's have a look at the triangles. If we'll see this triangle, the yellow triangle and the green triangle. Okay. Also, we'll see this BC is nothing but B plus C. So here this line segment is B plus C. And here this line segment will be same as A plus B. Now these two triangles we were talking about, these triangles have got one of the angle as 90 degrees. And if this angle is, let's say, theta, then the lines are parallel and this tangent is acting as a transverse. Your radiuses are parallel and tangent is acting as a transverse. So these angles will become your corresponding angles and these angles will be equal. So these angles will be theta and theta. Now this yellow and green triangle, from angle-angle similarity, we can say that they are similar to each other. So let's see here. First we name them. So this is A, D, This is BE and this is CF. And let's name this point as G and this point as H. So we know that yellow triangle is similar to green triangle. So yellow triangle is nothing but your DGE. This is similar to green triangle, which is triangle EHF. Triangles are similar, thus the ratio of the corresponding sides will be equal. So here corresponding sides I'm taking is DG and GE. So we are getting DG upon GE is equals to, similarly here it will be EH and HF. Let's put the value of DG. DG is nothing but A plus B. GE is B minus A. This is equals to B plus C. EH is B plus C and HF is C minus A. Sorry, HF is C minus P. Let's correct this one. So this is C minus P. We can solve it by componendo and dividendo, or otherwise we can do is simply cross multiply. If we'll cross multiply, we are getting here, this thing is A plus B times C minus B is B minus A times B plus C. Let's solve this. So we are getting this as AC minus AB plus BC minus B square. This is equals to B square plus BC minus AB minus AC. So we'll see here we are getting, okay, minus AB and minus AB is getting cancelled. BC and BC is getting cancelled. So we are getting here AC will take on one side. So 2 times of AC, what we are getting is 2 times of AC is equals to 2 times of B square. Now this AC and B square, AC and A, B and C, these are the radiuses. Let's put the value. A is nothing but 4 centimeter, B is 6 centimeter, and C is what we had to find. So from here we are getting 2 times of A is 4, C is what we have to find is 2 times of B square is 6 square. So this 2 is getting cancelled down. C is what we are getting is 9 centimeter. And this C is nothing but R3. So that's our final answer. That is, radius of the third circle is nothing but 9 centimeter. In fact, when these circles we are drawing, instead of 3, if we have 4 circles, 5 circles, then radius of all these circles will be in GP. The radiuses are in GP. That means that the ratio of their radiuses will be, consecutive radiuses will be same. So let's say if we have got here one more circle is there, and that circle is again tangent to the blue line with center lying on the black line. And here the radius is D centimeter. So when I'm saying radiuses are in GP, that means that the ratio of the radiuses, that is A upon B, will be same as B upon C, will be same as C upon D, and so on. I hope you enjoyed the question and its solution. See you in next video. Till then, tata, bye bye.